Heat transfer in nature. Pema and her brother Ferlin reside in Gangtok. On a cold winter evening, they are sitting around a fireplace. Alden shares his experiences of visiting Kerala during the winter vacation. He says that compared to Gangtok, winter in Kerala is comparatively warm and humid. Both Pema and Palden are curious about why some places are so cold and others quite hot. Hearing them express their curiosity, their grandfather, a retired science teacher, says Kerala is closer to the equator than Sikkim, and it also has a long coastline, which results in warmer and more humid weather conditions. Palden replies, yes, we learned in grade 6 science and social science that for us on the earth, the sun is the main source of heat and light, and around the equator, the climate is generally hot. As they are talking, Pema is keenly observing her grandmother cooking thukpa, a traditional Sikkimese dish in a large metal pan. Pema asks, why are cooking utensils generally made of metals? Weldon immediately responds that they had studied in chapter The World of Metals and Non-Metals that such materials are good conductor of heat. How does the heat get transferred in these materials? Let us perform an activity to learn why certain materials are good conductors of heat. 7.1 Conduction of heat. Activity 7.1 Let us experiment. Caution. This activity should be carried out under the supervision of a teacher or an adult. Take a strip of metal such as aluminium or iron, about 15 cm long. Attach 4 pins to the strip with the help of wax such that they are arranged at nearly equal distances, about 2 cm apart, as shown in figure 7.1. Secure the strip to a stand and label the pins as 1, 2, 3, and 4, as shown in figure 7.1. If a stand is not available, place the strip between two bricks for support. Heat the end of the strip that is away from the stand with a candle or a spirit lamp. What will happen to the pins? Will they remain attached to the strip or will they fall? Predict the order in which the pins will fall from the strip. Record your observations in table 7.1. Table 7.1 Falling of pins. Pin falling first. Prediction. Observation. Reasons for what you observed. You observe that the pins closest to the candle flame, pin 1, falls first, followed by pins 2, 3 and 4. Why does pin 1 fall before pin 2? Why did all pins not fall together? From your observation, what can you infer? Do you think that heat is being transferred along the metal strip from the end that is being heated? As the heat travels along the strip and approaches a pin, the wax holding it melts and the pin falls. Here the transfer of heat takes place from the hot end of the strip to the colder end. The process of heat transfer from the hotter part of an object to the colder part is called conduction. In this process, the particle that gets heated passes the heat on to its neighbor and so on. However, the particles themselves do not move from their positions. Materials like metals that allow heat to pass through them easily are called good conductors of heat. Because metals are good conductors of heat, we use utensils made of metals for cooking. In solids, the heat transfer takes place mainly through the process of conduction. If we use a strip made of material like wood or glass in place of a metal strip to perform activity 7.1, the pins will not fall. Can you think of the reason for this based on our learning from the chapter The World of Metals and Non-Metals? Materials such as glass and wood do not allow heat to pass through them easily and are poor conductor, insulator of heat. Clay and porcelain are also poor conductor of heat. That is why tea or coffee kept in such cups stays hot longer. List some materials around you and classify them as good or poor conductor of heat in table 7.2. Now I know why we generally use metal utensils for cooking, whereas we prefer clay and porcelain cups for drinking tea or coffee. Table 7.2. List of good or poor conductors of heat. Serial number 123. Material steel, wood. Good or poor conductor of heat. Steel is good conductor. Wood is poor conductor. Does your list include air? If it is where on the list, where have you placed it? You must have experienced that during winters, we prefer wearing woolen cloths to keep ourselves warm. Woolen fabric traps air in its pores, and as air is a poor conductor of heat, it reduces heat flow from our body to our surroundings. As a result, we feel warm. Similarly, air trapped between the layers of the cloth acts as a poor conductor of heat and keeps us warm. The presence of air between two thin blankets is the reason why we prefer them over one thick blanket to keep us warm. Is it possible to construct houses that are not affected much by the outside heat and cold? Houses constructed in places with a very hot or cold climate often use the concept of heat transfer to keep them cool or warm. Fascinating facts. The upper region of Himalayas, such as the Mori block of Uttarkasi in Uttarakhand, experience an extremely cold climate and heavy snowfall during winters. Houses here are often built to stay warm during winters with the with walls made up of two wooden layers filled with cow dung and mud between them. As wood and mud are poor conductors of heat, they prevent heat loss and help in keeping the houses warm. There are houses with outer walls that are constructed using hollow bricks that keep them warm in winters and cool in summers. This happens because the air that gets trapped in the hollow bricks is a poor conductor of heat. Pema draws Paladin's attention to the rising smoke from the burning firewood around which they are sitting. Why is smoke going up? In next video, we will read from 7.2 Convection. Heat transfer in nature. Pema and her brother Ferlin reside in Gangtok. On a cold winter evening, they are sitting around a fireplace. Alden shares his experiences of visiting Kerala during the winter vacation. He says that compared to Gangtok, winter in Kerala is comparatively warm and humid. Both Pema and Palden are curious about why some places are so cold and others quite hot. Hearing them express their curiosity, their grandfather, a retired